A major chemical hazard rating indicates that a chemical poses significant risk due to a high probability of occurrence and severe consequence if an incident occurs. Likelihood refers to how often or how probable a chemical incident may occur during handling, storage or disposal. It may depend by chemical's volatility, reactivity, frequency of use and quantity handled. For severity, chemical is rated by how serious the injury can be caused. Based on the experiment, we determined that sodium cyanide and hydrogen cyanide has the highest level of severity and they can cause the highest damage. And most of the chemical we use has the moderate level of likelihood, which means it can occur under normal operating condition.
Hi, everyone. Today I will be presenting about specific safety measurement of this experiment. First of all, as we all know, we need to wear lab coat and closed footwear, also our goggles and glove, which is PPE. And then next, we will need to have emergency and safety infrastructure in the lab to let us have immediate action when emergency happens. And then next, we need fire safety equipment such as fire extinguisher and fire blanket to extinguish the fire when the fire's accidentally been set off. And then last and foremost, most important thing is the ventilation and fuel cupboard, because this experiment have a lot of hazard thing. So we need to keep it inside the fuel cupboard to prevent inhaling too much hazardous fume or vapor.
So next, this slide indicates the major chemical-related hazards in the experiment. Major hazard refers to the most dangerous chemicals used in an experiment that can cause serious injury, poisoning, or death if exposure occurs. The main hazards used in these experiments are sodium cyanide and chloroform. Sodium cyanide is extremely toxic and can release hydrogen cyanide gas when in contact with acids, which is potentially fatal. Other than that is chloroform. Chloroform is a toxic organic solvent and can cause harmful effects if inhaled. Therefore, strict handling and proper ventilation are required when working with these chemicals in this experiment. So moving on to the next slide, which shows the major operational related hazards in this experiment. So the first hazard is heating under reflux, which can cause burns from hot glassware and fire hazards, especially when using a Bunsen burner. The second hazard is handling chloroform, which is toxic and volatile, and inhaling its vapor can cause dizziness and harm to the nervous system. Therefore, it must be handled in a fume hood with proper PPE.
So the next part is minor hazard. Minor chemical exposure refers to situations where chemicals are involved but the risk is low. For example, skin contact with mild cleaning product like diluted detergent or laboratory cleaners may cause temporary irritation such as redness or itchiness but usually not serious. Exposure to non-toxic dust or minor fume. When the laboratory has good ventilation, these substances do not build up in the air, so the risk to health remain low. Next one is sharp and glassware hazard, which can cause injury if not handled properly. Using the wrong tool for a task, such as using forceps instead of a proper holder, can increase risk. Minor cut may occur from broken beaker, slide, or pipette tips, especially if they are handled carelessly. Unguarded minor moving part on machinery can still pose a risk, even if they move slowly. While the injury risk may be small, all unguarded machinery should always be treated as a potential hazard.
Now I will present the emergency response plan for our experiment. The ERP is a set of immediate actions we follow in case of an accident or emergency to protect ourselves and others in the laboratory. So first, evacuate the lab in case of toxic cyanide gas release. If hydrogen cyanide gas is accidentally released, it can be very dangerous, so everyone must leave the lab immediately to avoid inhalation. Second, flush skin or eyes immediately if exposed to sulfuric acid. Any accidental contact with corrosive chemicals must be addressed by rinsing the affected area with plenty of water to reduce injury. And last, notify the lecturer or lab supervisor immediately for any chemical exposure or accident. Prompt reporting ensures that proper health and containment measures are implemented quickly.
Next, I will explain about disposal of chemical waste. Before we determine the method for chemical waste disposed, we need to identify the chemical by classifying it based on the hazardous and waste category. Based on our question, the chemical waste that we got is cyanide waste, chloroform, and 1-bromodicane. For cyanide waste, we collect it separately in a clearly labeled as cyanide and no acid, handled in a fume hood, and treated with chlorine or sodium hypochlorite bleach in alkaline high pH environment to convert to cyanide. The second is chloroform. We collect it separately in a hydrogenated organic waste bottle and proper labeling and secondary containment for collecting in containers. The third one is 1-bromodecane. We collect it separately in halogenated organic waste. We use a compatible container with a tight cap. We incinerate it on a high temperature in an approved hazardous waste facility.
Thank you for listening.